This lesson is on exponent properties. By the end of this lesson, you should be able to apply the properties of exponents, including the product, quotient, power of power, negative, zero, power of product, and power of quotient rules. Exponents, which indicate repeated multiplication, are extremely important in higher level mathematical study. The rules they play by, known as the exponent properties or laws, are critical to master, and there are the 8 listed. Exercise 1 is property 1, multiplication. So when we multiply, and they have the same base, we add the exponents. But remember, the base must be the same, okay? So same base, add the exponents. So we have x to the 13th. If there are numbers in front, coefficients, you still have to multiply those. So we have 5 times 6, and then we have x to the 4th times x to the 3rd. So this is 30 x to the 7th. Whew, we have a bunch of letters listed, so we are going to group the like ones. So x to the 3rd times x to the 6th, y squared times y. So we get x to the 9th, y to the 3rd. We don't have to put dots between them because when letters are listed in order, we assume that is multiplication unless there's another sign between them. Property number 2 is division. And again, you'll notice in the examples, this 2 has to have the same base, and then you subtract the exponents. So the bases are the same, so 8 minus 2 is 6. This one I'm going to work across because 6 over 12 is 1 over 2, or 1/2. X to the 10th over x to the 4th, subtract, is x to the 6th, because there's more on top, so the 6 that are left over are on top. And in the third example, now I have x's and y's, so x to the 6th over x, remember this has a 1, so that gives me x to the 5th. Y to the 3rd and y to the 2nd over y to the 2nd gives me y to the 1st, or just y. And there is no denominator. Or I could, if I wanted to, put a 1, but I don't have to. The third property is the zero property. And anything raised to the 0 power equals 1. So letter I, or the first one, 5 to the 0, is 1. Now you've got to be careful in the next one because it says 3 times x to the 0. So x to the 0 is 1. So I'm multiplying 3 by x to the 0, so 3 times 1 is 3. So be careful with your 0 powers. Or any powers, you need to know what the base is that it's attached to. In number 4, the fourth property, power raised to a power, you're going to multiply the exponents. So in the first one, x squared 3 times is x to the 6th. X to the 6th 5 times is x to the 30th. And this should all be review. Now exercise 5, property 5 and 6. We're going to distribute the exponent over multiplication and division of monomials. We're going to simplify each of the following also. So when I have an operation inside, unlike the previous one, I can't just multiply the exponents and leave it. There's multiplication in here. So I have to give this exponent to both of the bases, and their exponents are 1. So I have x to the 3rd and y to the 3rd. And the same thing is true for division. I have to give that exponent away to everything. I have to distribute that exponent. So I have x to the 3rd over y to the 3rd. So it's a combination of properties, okay? And they can't be simplified, so I'm done. In the next one, they have gotten more complicated. So I have to give it away to each base. Now, 2 is a base, and it has a power of 1. So 2 to the first to the third is 2 to the third. X squared to the third is x to the sixth. Well, 2 to the third in my calculator or my brain is 8, so I have 8x to the sixth. Again for I, 3 is a power of 1, so I now have 3 squared over x to the fourth. Well, 3 squared is 9, so I have 9 over x to the fourth. In the third one, I'm going to give away the exponents first and then simplify. So I have x to the sixth and y to the eighth over x to the ninth and y to the third. Remember, this has a power of 1. Then I'm going to use my division rule to simplify, and remember, only like terms. So I have 6 minus 9, or 9 minus 6 is 3. The 3 that are left over are on the bottom because the bottom is bigger. Y to the 8th over y to the 3rd. I have 5 left over, and they are on top because the top is bigger. Okay? All right. Property number 7, negative exponents, one of the harder of them. And remember, you can check your answers by storing values in the calculator and then putting the expressions in and putting your answer in just to verify that you didn't make any goofy mistake. Remember to move the negative exponents and make the exponent positive. All right. So the first one, remember the denominator is 1 if there isn't one. So I need to move this negative exponent, y to the negative 3, to the bottom and make the exponent positive. And I'm going to leave my x to the fourth on top. In the second one, well, if it's negative on top, and I mean the exponent, I have to move it to the bottom and make the exponent positive. If it's negative on the bottom, I move it to the top and make it positive. And it means the exponent positive. In letter I, or the third one, it's just like the first one. My denominator is 1. So to make this exponent positive, I move it to the bottom. And I'm not going to write x to the first. I'm just going to write x. And y to the negative 4 goes to the bottom and becomes positive. Well, I have nothing on top, so I'm going to write a 1. I have to write a numerator of 1. I do not have to write a denominator of 1. In the next one, the fourth one, I'm going to move x to the negative 2 to the bottom and make it positive. Y to the fourth stays on top. I'm going to move x to the negative 6 to the top, and I'm going to keep y on the bottom. And I am going to write a 1 to remind me. So I'm going to do my x's first. 6 on top, 2 on the bottom, leave 4 on top. 4 y's on top, 1 y on the bottom, subtract. So I have 3 y's on top. I have no denominator, so I don't have to write 1, or I could write a 1. In the fifth one, I now have a set of parentheses with an exponent outside, so I have to give this fifth power away. Remember to give it to the base of 2 and the base of x. So I have 2 to the fifth and x to the 15th, because power to power you multiply, over 8, and then I'm going to move this negative exponent, x to the positive 3, to the top. Now I must simplify. So 2 to the fifth over 8 is 4. And all I did was put that in my calculator, so let the calculator simplify for you. If you want to do it by longhand, go ahead. And these are next to each other, so that means I'm multiplying, so I add the exponents, so I get x to the 18th. And the last example has parentheses with exponents outside on both, so I'm going to do the numerator, and then I'm going to do the denominator, and then I'm going to simplify. So on top, I get x to the negative 6, y to the negative 8. On the bottom, remember that's a 1, so I have x to the negative 4, and y to the negative 12. Now I'm going to move everything and make it positive. So x to the positive 6 is on the bottom, y to the positive 8 is on the bottom, x to the positive 4 on top, y to the positive 12 on top. Now we're going to simplify. So the x's, 6 minus 4 is 2. There's more on the bottom, so I have x2 on the bottom. 12 minus 8 is 4. Since there's 12 on top and that's more, those 4 left over are on top. Take a second, pause the video, make sure you're okay with this, and then let's continue. Property 7, fractional exponents. Every fractional exponent can be rewritten as a radical and vice versa. So we have our form b to the m over n, and I really hate a sideward slant. It also would look like b to the m over n equals, the index is n, and we have b to the m power. So b to the m power is called a radicand. It's inside of the radical, and n is your index. Okay, so be careful with that, and that's all we're going to do. So make sure that we rewrite each expression in the form of a x to the b, where a and b are both rational numbers. So this radical is only attached to x. We've done this before, and we know square root of x. We know that the exponent is 1 and the index is 2, so this is x to the 1 over 2. And 5 is just being multiplied in front. Number 2, x to the 6th power, and my index is 4. Okay, so this is 7 over x. The power is 1. The index is 3, but I need it in this form, so how do I make this on the top? I make it negative, the exponent. So x to the negative 1/3. So to move something from the bottom to the top, I change the sign of the exponent. The 7 was just being multiplied, so the 7 really had nothing to do with that base and exponent. That's why the 7 just hung out front. So in the next one, we have an exponent of 1, so I have x to the 1/5 over 4. Well, what power is 4? It's a 1. So to move it to the top, I'm going to make it negative 1, and then it's being multiplied by x to the 1/5. That one was hard. Okay. And then the 5th one, it's just a square root, so we know that that index is a 2, so this is x to the 7/2. Okay. Remember, when it's an index of 2, we don't have to write it. And the last one, we want to rewrite it as 1 over x to the power of 2 over 3. To get it to the top, we're going to make that exponent negative. So go ahead, pause the video, make sure you're good with all of those, write yourself any notes that you need to, and then continue. Now in this section, we're going to go from those fractional exponents that we just created in the first part and make them into radicals. It says that we can rewrite each of the following without the use of fractional or negative exponents by using radicals. So in the first one, we know this means x to the 1st power, and the 6 is our index, so that is our radical with an index of 6. In the second one, we have x to the 3rd, and we have a radical with an index of 5. In the third one, the first thing we want to get rid of is that negative. So I know that it becomes 1 over x to the 1/3. And then I'm going to change 1/3 into x to the 1st power, which I'm not going to write, with an index of 3. Okay? So always get rid of the negatives first. Don't do the negatives inside the radical. That'll be crazy looking and it'll be confusing. So if it's a negative exponent, first make it positive. So move it and make the exponent positive. Then rewrite it in radical form. So I have x to the 7th, and I have an index of 2, which I do not have to write. If you do, it's not wrong. Now we're back to the positive. So I have x to the 9th with an index of 4. And the last one, I have 1 over x to the 2/11. And then I have x squared with an index of 11. So again, pause and make sure you're good to go, because we're going to do a little more thought-provoking questions on the next page and mix it up a little bit. So, although these problems can be challenging, the key will be to carefully apply the exponent laws. Why don't you pause and try letter B? Hopefully you got an answer of x to the third over y to the third. In letter C, I have some negatives. So first I'm going to take care of those negatives. So x to the positive 2 goes on the bottom, y to the fourth stays on top. X to the negative 6 on the bottom becomes positive on top, and y stays where it is. Now I'm going to clean it up. So x6 over x2 is x4, y to the fourth over y is y to the third. So why don't you pause the video and try letter D. And you can see my steps. First I distributed the exponents, then I fixed the negative exponents by switching their position, and then I simplified. If you have any questions on those that I did by myself, please ask in class. Do the same situation for the next set. So in letter A, we are simplifying each of the following will leave no negative exponents in the answers. So a negative exponent, we are going to move to the top. So this becomes x to the positive 3 over 2. In letter B, when we multiply, we add the exponents. So if you don't want to do that in your head, go ahead and do it on the calculator. And you should get 5/6. So we have x to the 5/6 over x to the 1/6. When I divide, I subtract. So again, if you can't do that in your head, then do it on the calculator. 5/6 minus 1/6 is 2/3 or 4/6, which simplifies to 2/3. So this is x to the 2/3 because 5/6 is bigger than 1/6, so there's more on top. These are hard, so make sure you practice these. In letter C, I'm going to distribute that exponent first. So we get x to the 5/2. So again, if you can't do that in your head, use your calculator. Over, and these are going to be multiplied, so the exponents are going to add. So if you can't do that in your head, do it on your calculator. So we get x to the 9/2. Now the problem, 9/2 is bigger than 5/2. So my answer is going to be on the bottom. So what's 9/2 minus 5/2? Which is 4/2 or 2. So I have x to the 2 on the bottom with a 1 on top. And the last one, I have to distribute the exponent on top. So I'm going to have 4 to the third and x to the second. So 2/3 times 3. I did in my head, but if you need to use your calculator, go ahead. You get 2. And then on the bottom, I have 32x to the 8. So 4 to the third is 64 divided by 32 is 2. I'm going to subtract these and notice bigger on the bottom, so I have x to the 6th on the bottom. So again, the numbers I just put in the calculator. I just did 4 to the third over 32. Okay? Fractional exponents are tricky. So the last set. We have x to the 5/2 over x to the 4/3. So subtract, because we're dividing, 5/2 minus 4/3, and we get x to the 7/6. In letter B, I need to distribute this 2/3 to both 8 and x. So I have 8 to the 2/3 and x to the 10/3. Well, 8 raised to the 2/3 is 4. So 4 times x to the 10/3. Ooh, in the last couple we have radicals and exponents mixed, so I'm going to rewrite this radical as a fractional exponent, so 1/2, and x to the third. When I divide, I subtract, so 3 minus 1/2, and many of you will say 2.5, but remember we want fractional exponents, so we have x to the 5/2. Okay. And letter D, we have to give this 1/3 away to both bases, so we have 27 to the 1/3 and x to the 1/3 over 6. Let's rewrite that radical as a fractional exponent, so 1/2. 27 raised to the 1/3 is 3, so I put that in my calculator. 3 over 6 is 1/2. Now, same base, I'm dividing, I subtract, so 1/3 minus 1/2 gave me a negative 1/6, but I don't want a negative 1/6, so which one's bigger, 1/3 or 1/2? Hopefully you know 1/2 is bigger. So x to the 1/6 is on the bottom. I don't want the negative in there, so I should have done in my calculator 1/2 minus 1/3. If you have any questions, please make sure you ask in class. Good luck!